Large language models are powerful, but they are blind to the data inside your private company files. Retrieval Augmented Generation, or RAG, is the standard process for feeding that specific information directly into the model's prompt. Many developers are currently approaching basic data retrieval tasks with heavily engineered, enterprise-grade architectures. Teams are building incredibly dense multi-database systems just to answer simple questions about a 50-page employee handbook. The industry conversation is pushing highly complex frameworks, specifically Agentic RAG and Graph RAG, as the new default standards you need to implement immediately. Climbing the RAG complexity ladder has distinct trade-offs. As you add layers of sophistication, your API token costs grow, you create more points of failure, and commit to ongoing maintenance. This quadrant chart maps the effort required against actual operational impact. The simplest method, pasting your document, sits here. High impact, near zero effort. Conversely, Agentic Graph RAG takes months of setup. You add massive weight for a marginal accuracy boost. Sophistication should be driven by operational necessity. To decide how much engineering your project actually needs, we can categorize your options into a 3-tier framework based strictly on your data volume. Tier 1 is for small, contained datasets. If you are working with an internal company wiki or a policy manual under 500 pages, this is the most efficient starting point. At this scale, you can use Level 0, context dumping. Modern language models now have million token context windows, meaning you can paste your entire document directly into the prompt every time a user asks a question. This bypasses database engineering entirely. There are no vectors or retrieval algorithms to maintain. You get instant deployment and high reasoning accuracy because the AI can analyze every word of the source text at once. The primary trade-off is financial. By sending the entire handbook for every single query, you pay a higher inference token cost per question. If that cost becomes an issue, you move to Level 2, Smart Chunks. You use a secondary, cheaper AI model to read the incoming question and select only the specific chapters needed for the final answer. But this introduces a retrieval risk. If the cheap AI selects the wrong chapter up front, the main model is blind to the correct information. The final answer will be an unavoidable hallucination. Tier 1 forces a choice. You trade long-term cost efficiency for immediate deployment speed and zero architectural maintenance. Tier 2 is the necessary architectural upgrade for when your data exceeds millions of pages. At this volume, brute forcing the context window becomes physically and financially impossible. This requires traditional vector RAG. Your text documents are converted into numerical representations called embeddings and stored in a dedicated vector database. When a user asks a question, the system retrieves only the top few most relevant paragraphs. This allows you to query millions of pages of data for pennies per search. The core vulnerability here is semantic noise. Because the database searches for mathematical similarity, a specific query for a product error code might return 10 vaguely related paragraphs instead of the exact documentation you need. To eliminate that noise, developers use Level 4, Hybrid RAG. This combines mathematical semantic search with a traditional exact keyword search index. Cautionary: this creates a dual maintenance burden. Developers must actively synchronize a vector database and a standard keyword database. If they fall out of sync, your retrieval accuracy drops. You also have Level 5, Contextual RAG. To prevent the AI from giving instructions out of context, the system is programmed to grab the surrounding paragraphs of any retrieved answer, ensuring the AI sees the prerequisite steps. Tier 2 achieves infinite scale and low query costs, but it requires days of initial setup and continuous database maintenance to function correctly. Tier 3 represents the bleeding edge, reserved for environments with highly interconnected data, such as global supply chains or complex pharmaceutical research. Level 6 is Agentic RAG. Instead of a simple search, you deploy autonomous AI agents. They analyze a user's question, strategize a search, evaluate the findings, and automatically retry with new parameters if the first result is insufficient. Autonomous agents can misfire. If an agent misinterprets its findings, it can spiral into recursive searches, looping hundreds of times and generating thousands of dollars in API bills in a single afternoon. Level 8, Graph RAG, abandons simple document lists to map explicit relationships between entities like employees, products, and specific customers. This enables multi-hop reasoning. To find which engineer has the most experience with a specific client's issue, the system traces a path from the customer to their products to the specific employees who resolved past tickets. The trade-off is extreme fragility. A single broken relationship link or a formatting error in how an entity is defined cascades across the map, rendering the entire network useless. Tier 3 provides the ability to track these complex relationships, but the infrastructure is brittle. It requires a dedicated AI engineering team to constantly update entities and mediate agent logic. To choose the right architecture, we can use a diagnostic framework based on your specific data constraints. First, check your document volume. Are you working with less than 500 pages of relatively static text? If yes, start with Tier 1, Context Dump. For pragmatic bootstrappers, saving weeks of engineering time makes the higher token cost per question a justifiable expense. Second, evaluate your scale. Do you have millions of pages and require fast, cheap search for thousands of daily users? If yes, you need Tier 2, Hybrid RAG. For scaling operators, absorbing the initial database setup time grants the cost efficiency required to run a platform at volume. Finally, does your use case require tracking highly complex, cross-functional organizational data? If yes, look at Tier 3, Agentic Graph RAG. For enterprise architects, managing highly interconnected data justifies the infrastructure and the team required to maintain it. The most effective AI deployments rely on the simplest possible architecture that consistently delivers the necessary result.